Welcome to clickmyproject.com. Our product title is Simulation Studies of Inverted Pendulum based on PID. Let us see about the abstract of our product. In this proposed implementation is done only the control algorithm of the inverted pendulum is created in the MATLAB Simulink and file coding. The inverted pendulum problem is one of the most important problems in control theory and has been studied extensively in control literatures. When a control system has more than two controllers, the adjustment of GA parameter is not an easy problem. In this proposed system, GA controllers are applied to the stabilization and tracking. Control of three types of inverted pendulum. The way how to design the GA controllers is given step by step in this proposed system. Simulation results prove that the way to design of GA controller is very simple and effective. The system design not only can realize stabilization and tracking control of three types of inverted pendulum, but also have robustness to outer large and fast disturbances. In this process is to implement of genetic algorithm insist of PID controller. Here get the output value into workspace, then that value load into GA. In GA they provide one optimized value. In that value is saved in a mat format. That mat file is given into the pivot, and also this output is compared with the applied the PSO, that means the particle swarm optimized algorithm. Then the output also calculated, and also same procedure is followed for that algorithm placed. Then the output is compared with the GA. Next we see about the flow diagram. In the flow diagram, the optimization is GA optimization, then save in mat file the output of the optimized value, then call the mat file into the inverted pendulum pivot section, and that pivot section that output will be shown in the corresponding Simulink scopes. And also the structure and model of X inverted pendulum. The X inverted pendulum on a pivot driven by a horizontal control force. The control action is based on the horizontal displacement of the pivot. The total kinetic energy and potential energy of the X inverted pendulum, where xp is equal to x and is the distance from the pivot to mass center of the pendulum. The inverted pendulum control was split in two main bases, the swing up base and the stabilization base. The former uses of a non-linear controller to swing up the pendulum, keeping the cord within a limited travel gauge and on the coil. The latter uses a linear state feedback controller to stabilize the pendulum in the inverted position once it approaches the upper unstable equilibrium point. It is also required to hold the cord to a reference point on the rail. Once the pendulum is stabilized, a transition algorithm switches smoothly from one control base to the other. This technique aims at swinging up the pendulum, which keeping the cord within a limited horizontal travel on the rail. This is actuated by satisfaction a particular mathematical conditions derived from the mechanical energy equations of the pendulum. While constructing a linear servo system using a sinusoidal reference input generated from the pendulum trajectory, this control method is based on the state space ball placement design techniques using the linearized model of the inverted pendulum. This implies that the stabilization control by itself will only ensure local stability in the upgrade equilibrium point, the point about which the equilibrium was linearized. The pole placement technique permits the design of a linear controller. Next we see about the running process of our product. In this proposed implementation is done in MATLAB Simulink environment, and in this process we done in the two kind of fields. One is the MATLAB Simulink and another one the M file. The output of the MATLAB Simulink is fed into the M file, and that value is considered to comparison of several algorithms. One is the GA, another one is the PSO. So those algorithms, the computation optimized value can be get, and that value is fed into Simulink as the input. So here in the command window, the iteration time and also iteration cycles all are given. Next, in the MATLAB Simulink environment, create a model file. After creating that, we using commonly used bug, then arrange the elements as per the flow diagram. After that, we click the run icon, then the simulation will start to run. After, when the simulation will be entered, the scope is open, then the output waveform will be shown. So this is the output waveform of inverted pendulum, and this is the x of angle of the inverted pendulum, and this is the input is getting from the M file coding. And next one is the angle of x for inverted pendulum, and x-axis is the iteration cycles, and next one is the position of x for inverted pendulum and iteration cycles, and this is the fitness function using of these positions. Thank you for watching this video.